Professor Deb here. This is a video on technical mathematics. There are several videos that go along with this regarding technical mathematics. This particular video will be on laws of radicals. There are 3 in a series in regards to exponents and radicals. Let's get started on this subject. Here's some rules for radicals. First of all, we have to understand the definitions. This part right here, the n, refers to the root, order, or index. I commonly use root. And anything underneath the radical sign is referred to as the radicand. Alright, now let's discuss some of the rules. When you have a radical that has a root, you can split this multiplication of variables into 2 radicals with the same root. That'll be advantageous when we're simplifying. And the same thing when I have a large radical with a division of variables. I can split that into individual radicals. One on the top with the same root and one on the bottom with the same root. Alright, this we discussed in an earlier video, but let's go over it again. We have the root of a radical raised to the same root. If this were 4, the 4th root, and it was raised to the 4th, it would equal the variable b. And also, when we have the radical b with the nth root, that can be rewritten as b to the 1 over, and that should say n there, 1 over n. Okay. Here's our first problem. 3rd root of 40. Now, we can rewrite this. Let me get my pen here. We can rewrite this as the 3rd root, but we can break this up into 8 times 5. Now, why would we want to do that? Let's look at it a little further broken down. The 3rd root, and we have 2 times 2 times 2. That equals 8, doesn't it? Times 5. Okay, so right here we have 3 2's that we can take outside the radical. So that becomes 2 radical, and what we have left over in there is a 5. 2 radical 5. That's a simplification of what we started out with. Let's try another one. Alright, now this time we have a variable. And this b is raised to the 10th, and we need 7. Now again, the same way as we did with numbers, we can break this down into 7 b's, and then what do we have left? 3. And this is the 7th root again. So we can take 7b's to the outside. So let's do that. That comes out as 1. So when we have 7 and a root of 7, it comes out as 1b. And what do we have left in the radical? We'll put our root here. We have b cubed. And we're going to keep working along this way. So, but first, why don't you try one? Stop the video and try and work the problem, and then look at the website under Solved Solutions. All right, ready to continue? Here's another one. All right, now in this case we have p to the 12 and y to the 8. We're going to break that down again. We're going to still keep doing this until you get used to it. We have the 5th root. Now, how many p to the 5's do we have? We have p to the 5. To the 5. That gives us 10. So we have 2 more left over. Now out of the y's, we have y to the 5 and y to the 3. Let's extend that a little bit. Now we decide what we can take out. We can take this p to the 5 and this p to the 5 and this y to the 5 to the outside. All right, let's try and do that. So we have 2 p to the 5's. Remember, each p to the 5 comes out as 1. But in this case, we have 2 of them. We have one here and one here. And we have a y to the 5 that comes out as y. And then we leave in there what we have left. We still have 2 more p's that we can't take out of there. There's our 5. And we have 3 more y's. So we've simplified this equation by taking out what we can to the outside of the radical. All right, starting to get the idea? Okay, here we have a problem. All right, now what can we break that 32 down? We have a cubed root. So let's see, we could start with 2 cubed. Let me not forget our radical sign. Okay, we have 2 cubed. What does that give us? Okay, 8. And 8 times 4 is 32. So we still have 2 squared. And we have a to the 3rd and a squared, and we still carry our b squared. Okay, we take out what we can. Here's 3 of the 2's, and here's 3 of the a's. And we can't do anything with this b squared, so we'll just leave that in. So we'll bring out 2, and we'll bring out a. And we'll leave what we have in there. It's the cubed root. Don't forget that cubed root. And what do we have left? 2 squared. Well, we can rewrite 2 squared. 2 squared is 4, right? is 4. And then we have a squared and b squared. All right? In this problem, we're going to multiply two radicals together. Now, they have the same root, so we can multiply them together. We can actually put them all together. So let's put it underneath one radical. Sixth root. We have m to the third. I'm going to pick up that, and I'm going to pick up this. M to the second. I'm going to pick up n to the second. Come on here. N to the second. And n to the fourth. And we still have e. And this e. Oh, what a mess that is. So let's clean that up a little bit first. Remember, when we multiply variables, we add the exponents. So we'll put this as m to the fifth. N, we add the exponents to the sixth. And e, that'll be to the 12th. All right, now let's look at it again. We can take n to the sixth outside. And this we can really break up into e to the sixth times e to the sixth. So we can take both of those out here. Okay, let's rewrite it. We have n to the sixth that comes out as 1. And we have 2 e to the sixth. So remember, that comes out as e squared. We have 2 of those. We have to keep our root in there. And what we have left is m to the fifth. All right? I think you're ready. Try this one. Now remember, break up the 81 so that you can bring anything to the fourth out. Like try 3. What's 3 to the fourth? And then break up your 9 into fourths. Stop the video and try this. All right, hope you got this one. Let's try a little more complicated one. All right, let's see. Whoops, we don't have a negative 2. Did I skip that? No. All right. We have a to the third over b to the ninth and c to the sixth. Now, if you remember what we said in the beginning, we said we can take this big, huge radical and we could split it up over the numerator and over the denominator. And I think that'll make it easier for us. So let's try that. Okay, we've got the cubed root of a to the third. Now let's skip a step and go ahead and write this out. So we have b to the third b to the third. c, oops, we got to put our radical down there. Third, b to the third, or c to the third, and c to the third. Oh, I'm sorry. Here's b to the third. That gives us 6. We want one more. That's what I was a little confused about. Okay. So we have 3, 6, 9. That makes a lot more sense. All right. Now, let's take out what we can. We can take out the a and the b's. So we have 1a. 1a to the third comes out as a. And we have 3 b's. So remember, that comes out as b to the third. Okay, now what happens on the bottom? 2c to the thirds come out. Look at that. We simplified that, and now we don't even have a radical sign anymore. So that's really simplified that. All right, let's try this one. All right. What are we going to do with this? We shoved it over here on the side so that we can work with this a little bit. Let's start breaking it up. Whoops. That's 2 to the third. 2 to the third is 8, right? Okay. We have a to the third. And a squared, that gives us 5a's. And b to the third. Now we'll solve that bottom. Oh, what did I forget? Forgot that root up there. Common mistake. Okay, 3. Let's see, we could put 3 to the third. 3 times 3 times 3 is 27. We've got r to the third and r to the third, s to the third, s to the third, and s to the third. That's a lot of 3's there. Let's see what we can do with it. We can bring the 2 out, we can bring the a out, and we can bring the b out. What we have left in there is a squared. Now on the bottom, we bring out 3 and r squared, because we have 2r to the thirds. We have 3s to the thirds. And there we have it. Much easier to work with this equation. All right. Try this one. Stop the video. Try to work it out. All right, now we're going to get a little more complicated. Sometimes when we broke them up, we had something on the bottom that could come out of the radical. But sometimes we will not be that lucky, and we have to get rid of the radical sign in the denominator. The radical sign always has to be eliminated in the denominator. So first, let's look at the terms. N again is referred to as the root, order, or index, and I commonly use root. Now, a over b is a fraction, and that is referred to as the radicand. All right. First, we remove all possible factors from the radicand. So anything we could take out, we take that out from the very beginning. And then here's our new term. Rationalize all the denominators. That's what we're going to learn in the rest of the video. Reduce the index as much as possible. Alright, now what is this rationalize the denominator? This is when we multiply the denominator and the numerator by equivalent radicals to eliminate the radical. So if I were to take something here and I were to multiply it by radical 3 over radical 3, would I be changing this? No, because I'm actually multiplying it by 1. So you'll see how rationalizing the denominator will get rid of our denominator. Let's take a look. Let's get some actual problems here. Okay, we put this over to the side again so that we can work on it. Alright, now we'll split this up. Just like we did before, 3 of negative 2 and the cubed root of 25 r squared. Alright, now to rationalize the denominator, we have to get rid of, let me rewrite this one more time, okay? I think you'll see it a little easier. Really, this is 5 squared, right? 5 squared is 25, and we have r squared. Alright, now what we have to do is get rid of this radical sign. So in order to do that, we said we needed 3 of these to bring it out, and we needed 3 of these to bring it out. So what we have to do is multiply this by the cubed root of 5r. Cubed root of 5r. Now this is what I was trying to explain earlier, was as long as we multiply by the numerator over the denominator being the same, then we're only multiplying by 1. Now what this does is it gives us 2 5s here and a 5 here. So that can come out of the radical sign as 5. We have 2 r's and 1 r here, so that can come out as r. Okay, this is what's called rationalizing the denominator. Actually, what we're doing is getting rid of the radical in the denominator so that it's easy to work with. You cannot have radicals in the denominator. Okay, so now what we have up here is negative 2 times 5 and r, and we have to keep our there. So we can just rewrite that as cubed root of negative 10r over 5r. And trust me, that's going to be easier to work with in the long run. Alright, let's keep going. Alright, I think we can do this one. And we've got the same thing, only this time we've got the 4th root. So we're going to break everything up into 4s. Now, can you see where we're going here? We have 16, and we have 3 c's. We're going to need 4, so we're going to add 1 more. And we have 6 here. We have to bring that to 8, so we're going to add 2 more. So let's I'm sorry. So the 16, let me get some thickness to this. No, I didn't want to do that, so I'm going to kind of make it a little big here. A squared b cubed. And we're going to put that. Remember I said we were going to split the radicals? And what do we have? Oh, we want 4, so that would be 2 to the 4th. Let's check that. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yes. 2 to the 4th, c to the 3rd, and I'm going to break this out again like we used to. B to the 4th times b squared. Darn it. I'm forgetting those roots up there again. Okay. So, let's take out what we can first and simplify it. So we don't touch the top. Put that 4 in there. A squared and b cubed. Now let's take out what we can first before we rationalize the denominator. We can take out 2 and we could take out b, right? And then what do we have left in there? Keep our 4. This is gone. This is gone. We have c to the 3rd, b squared. Okay, now I've got to get rid of this radical. So here I am again with 3 c's, and I need 1 more. And I have 2 b's, so I need 2 more. So what do we put in here to rationalize? We need 1 more c, and we need 2 b's. Okay, very good so far. Alright, now let's do the multiplication of it. Back to black. Okay. So that's going to take our c out and our b out. So let's write that bottom. That's going to be the easiest. We have 2b, and we're going to bring out now a c and another b. We can simplify that and put the b's together, right? But let's get our top down here. Let's see what we've got here. We've got the 4th root, and we've got 25. We're not going to be able to do anything with that. And we've got a squared b. Now we've got 3 and 2. So we've got b to the 5th, and let's not forget our c. Okay, now let's simplify the whole thing. We're going to do it all in one swipe. Okay, what can we take out? Well, we've got 4 b's here, so we'll take that out as b. Can't really do anything more. Let's see. The 25 we can't take out. The a squared we can't take out. And we only took out 4 b's. I used to write this out as b4, b1, but I think we've got the idea now. So we leave one b in there, and the c we can't do anything with. And what do we have on the bottom? 2. We're going to combine the b's, b squared and c. Now you think we're finished? Not quite. See, we've got a b up here in the numerator outside the radical, and we've got b's down here. And we go back to an earlier video where I used to use the phrase, put where the most is. Okay, so we've got a b here, and we've got 2 down here. We can change that to just 1. So now what is our final answer? A squared BC over 2C. And that is our final answer. All right, let's see what we've got. I've got one for you. Spread this out into what 3's you can have. And then remember to put a radical on the top, a radical on the bottom, and you're going to rationalize the denominator so that you could take 3 of something to the outside. Stop the video and try it. Ready to continue? All right, we've got a little bit different way of writing things here. If you're familiar with scientific notation, it always has 1 place before the decimal and 10 to the 14th. All we're going to do is write this longhand and bring out how many 10s we can bring out. So first of all, we need to change this, because we don't want to work with 3.2. What we want to really work with is 32. And when we increase the number, we decrease the exponent, so we have to take that to 10 times 13. Okay, we can rewrite this. Let's see, I think we've got 2 to the 5th. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. All right, 2 to the 5th. Now, I'm going to write this out this time, even though we said we were going to stop doing that. We've got 2 to the 5th. I'm sorry, 10 to the 5th, 10 to the 5th, and 10 to the 3rd. Let me extend this a little bit. So what can we take out? 2 times 10, and we've got 2 of those to bring out. So that's 10 squared. And we keep what's left in there, 10 to the 3rd. Now we don't want to leave this with exponents all over the place. So 2 times 10 squared is 200. And that'll be the 5th root, and 10 cubed is 1,000. All right? So the only thing different here is you're moving the decimal place to write the exponent. Then you're taking out what you can. And all you need to do is take out however many 10s you can. Okay? I'll give you one to try. Try this one. Now in this case, I made it easy for you. You don't have to move the decimal place in the 16. And you're working here with square root, remember. Even though there's no number, it insinuates square root. All right? Stop the video and try it.